In this video, I'm going to talk to you about modes of heat transfer. Modes of heat transfer. Now, as we all know, heat always transfers from the body at a higher temperature to the body at the lower temperature. So, let us say there is some body at temperature T1 and there is some other body which is in contact with this body and is at temperature T2 such that T1 is greater than T2, then heat would flow from this body to this body. Now, this is called transfer of heat. But how this heat transfer takes place? Now, this answer is not given by thermodynamics, and we need to study the modes of heat transfer to know this. Now, basically, there are three different modes of heat transfer. First one is conduction. Conduction. Second one is convection. Second one is convection. And third one is radiation. Third one is radiation. And these are the three major modes. These are the three only modes of heat transfer, and now we will study each of them one by one. Now let us start with the conduction. Usually in practice, the heat transfer takes place a combination of the two modes. Only one mode is not responsible for the heat transfer, but here we are going to study them individually. Now, first of all, we will understand conduction. So first one is conduction. Conduction, as the name implies, is to conduct. To conduct. To conduct. Okay, so consider this lattice structure or arrangement of some atoms like this and this. Okay, these are some circular atoms which are in contact with each other, and this is just an example. I don't know how the exact lattice structure would be because I don't know what particular element I'm talking about over here. It is just an example to explain the mode of conduction. So this is some lattice structure. Okay, now all these are in contact with each other. Now suppose there is some temperature gradient over here. Say temperature over this hand is maximum and over either hand is minimum. So temperature gradient is in this direction, that is temperature decreases as we move from left to right. Temperature decreases as we move from left to right. Now, so this here it would be the maximum temperature and here it would be the minimum temperature. So, and here there would be intermediate temperatures. Now, this is the initial condition, and the final condition would be such that entire lattice structure would be having the same temperature. And now this is about solids. This is about solids. Yes, this happens in case of solids. Now, as this segment of molecules or atoms has a higher temperature, they tend to vibrate more intensely, and just because of their vibrations they lose energy, which gets imparted to the next layer or the next segment, which further gets imparted to the next segment, and likewise the energy is conducted, and this energy is manifested in the form of heat, and as a result temperature of the entire structure becomes similar. So this kind of heat transfer where conduction takes place due to lattice vibrations, conduction takes place due to lattice vibrations, is heat transfer. This is for the case of solid. Now, the second way in which the heat transfer takes place in conduction is due to the presence of free electrons. As you all know, there are a certain amount of free electrons that are present in lattice structure that are free to move along an entire lattice structure. Now, these electrons can also impart heat. As they move from a higher temperature segment to the lower temperature segment, they carry the heat and transfer it to the lower temperature segments. So the other way is via free electrons. The other way is via free electrons. Now, these are the two ways in which conduction takes place in solids. Now this was all about solids. Now the second thing would be, let us consider, uh, we would have to consider gases. Now as we all know, gases are less densely packed. As a result, they have some intermolecular spaces. Let's consider this container, and these are the molecules of gases or atoms of gases. As you can see, the condition of uh, solid was quite packed, whereas gases have far more intermolecular distances. This is called intermolecular distance. The distance between two molecules is called intermolecular distance, and it's quite more in case of gases as compared to uh, solids. And second thing, the fact about the gases is, for gases, kinetic energy kinetic energy is a function of temperature. Kinetic energy is a function of temperature. So more the temperature, more is the kinetic energy of the molecule. So less temperature, less is the kinetic energy of the molecules. So suppose temperature of some molecule is far more than temperature of the other molecules, then that particular molecule, say this is the molecule with a high temperature, this is the molecule with a little bit higher temperature, and so this will have more kinetic energy as compared to this molecule which has low temperature. Obviously atoms would be of same color if they are of same element. Just to explain you, I'm showing it with the different colors. Now this molecule will keep moving. As we all know that gases have a high mobility, so these molecules will keep moving here and there, and when this molecule collide with this, it will impart its momentum as well as energy to this another molecule. As a result, the another molecule will also gain some energy and will become bit more energetic. So and the energy will of the molecule with lower energy would increase, while the energy of the molecule with higher energy will decrease, and likewise the energy transfer takes place, and this energy transfer is in the form of heat, and this is how heat transfer takes place in gases when we consider the case of conduction. Same works for gases, liquids. Liquids, uh, liquids case is quite similar to gases. There is nothing more to discuss in case of liquid. The only difference is the intermolecular distances are quite low. The intermolecular distances are quite low, and so intermolecular forces also play some role in heat transfer. However, uh, there is not much difference, and there is nothing much to say about it. So you can just assume that the heat transfer in liquids takes place in just same way as in case of gases. So that was all about conduction in solid, gases, and liquids. Now next thing we will talk about is convection. Is convection. Convection. Now what is convection? Now over there was a heat transfer due to some physical contact. Atoms or molecules used to collide with each other and transfer their heat. In convection, uh, the heat transfer takes place due to mixing. Heat transfer takes place due to mixing of fluids. Let us say for example, this is just an example. So there is some uh, water over here, and there is some uh, water with some different temperature over here. Now don't think that water is a magenta color. This is just to show you, otherwise water, pure water always have same color. Now these water are of two different temperatures, and the temperature of this is say T1 and this is T2. Now this one is a colder, relatively colder, so T1 is less than T2. Now what will happen is the water with a higher temperature, water with high temperature has lower density. So what will happen is the density of cold water will be more, and as a result the gravitational force acting on this water will be more, and as a result there will be kind of circulation that will be formed within it. So the cold water will tend to move downwards, whereas the hot water will tend to move upwards, and as a result the situation may change somewhat. Obviously there would be some heat transfer along in between them, but ideally there would be a convection. The entire shift of cold water below the hot water will take place, and this is how convection process works. But convection uh, is possible only for fluids, means gases and liquids. It does not happen for solids. This does not happen in case of solids, because solids can't flow, so how are they going to shift over here like this? So this is possible only in case of uh, liquids and gases, that is fluids. And this is all about convection. Convection principle is used in solar water heater. Solar water, oh oops, I made some mistake. Solar water heaters, and these are natural circulation solar water heaters, and there is some entire tutorial for this also, entire video that explains the working of solar heater, and there I explained how convection is used there. But this is the principle that works over there, that convection mode of heat transfer. And the last one is the radiation. Now what are radiations? Irrespective of what we are talking about, radiations are something rays basically that can travel in vacuum even. Say for example light. Suppose sun. This is sun, and sun is smiling at us. Yeah, and this is earth, and this is earth, and the the space over between the sun and earth is vacuum. Is vacuum. Still light from the sun can reach earth, also heat can also reach earth. So how is it possible? These this kind of transfer of heat is called radiation. This kind of transfer of heat is called radiation. Now so these are basically the form of radiations. If you want heat to transfer in vacuum, it can with the help of electromagnetic radiations. Electromagnetic radiation is a peculiar property. They can simply travel in vacuum even. They do not need any medium. Electromagnetic oops uh, magnetic waves do not need medium to travel. They can travel in vacuum even. So suppose this is some body A, and it's surrounded uh, by vacuum, and there is some solid body over here. Yeah, this is another body, and the temperature of this is greater. The temperature of this body A, TA, is greater than T surrounding, and this portion is vacuum. Then also heat transfer can heat transfer can easily take place with the help of radiation, and it will start radiating heat in the surrounding area till the time the temperature of the surrounding area will become equal to the temperature of this body. And this is how radiation mode works. So today we understood the three basic modes of heat transfer: conduction, convection, and radiation. I hope you found my lecture useful, and thanks for watching my video.